Hi again, as I promised, I'm going to finish the radicals section for grade 11 math. At the end of this video, you'll see a link to the rest of the radicals, so you could watch the whole thing. So I'll have two videos covering the whole radicals. So the link will be at the end of this video. So click on it and you'll see the start of this chapter anyways. Okay. So just as a reminder from yesterday's lesson, we should know the perfect squares and the perfect cubes, and that's how they go. Of course, they continue forever. You have infinite number of perfect squares and perfect cubes. What I added today to the radicals chapter is that if you have the b root of x to the a, where b is the radicand, so it could be a cube root, it could be the fifth root, it could be whatever, and a is the exponent on the x, you could change that into, look at that, I just wrote something wrong. That could be changed to x to the power of a over b. So the exponent becomes the numerator and the radicand becomes the denominator of the exponent on the x. So all of this just becomes an exponent, and that will be using it. We will be using this rule for this question right here and this question when we get there. But now let's go to this first question here. So 3 root 2 brackets 5 root 7 minus 4 root 3, that means multiplied, or the property of distribution, we have distributed that into here into there, so just multiply right through. So 3 times 5, you multiply the rational numbers together, 15, and then the radicals, you multiply them together and you get root 14 minus, and then 3 times 4 is 12, and 2 times 3 is 6, so that's root 6. These are not like terms, so we cannot add them. Also, we cannot simplify the radicals any further, because there's no perfect square that goes into 14, 4, 9, 16, doesn't go into that. And also nothing goes into 6. So that's the final answer. Fast and easy and quick. Here we have 2 brackets. So this is distribution again. So the property of distribution, but it's foiling. So we multiply first into the second, and then the second from here into the first, the second into the second. So to do that, I'm going to get 2 times 2 is 4. Minus, or sorry, 2 times positive root 3 is plus 2 root 3, and then negative root 3 times 2, that's just negative 2 root 3, and then negative root 3 times positive root 3, it gives you 3. So you don't have the square root anymore, because honestly, it's actually, it's square root of 9, and the square root of 9 is 3. So when you multiply a radical by itself, just get rid of the square root, or you could write that as square root of 9 and then later do it, change it to 3. So now this will give me 4 minus 3 is 1. And these two, they are like terms and they're opposite signs, so they cancel each other out. And we get 1 as a final answer. Sometimes when you recognize this, the difference of squares, you could just multiply first by first, you get 4. And multiply last by last, you get negative 3. 4 minus 3 is 1. Because when it's the same thing and difference of squares where you have one is negative and one positive in the middle, the middle is always going to cancel. So this shortcuts you could take if you feel comfortable with doing that. Now, how about here? Now, the mistake that students make in this question, they say, hey, I'm going to square this, and then I'm going to square this, and I'm done. No, so they cannot do that, because if you have 5 squared, it means 5 times 5. So if this is squared, it means this times this. So what you have to do, you have to write it twice and start foiling and doing the property of distribution. So here you need to write this as root x plus 2 root 5 times root x plus 2 root 5. So that's what we're supposed to do right here. Now let's start foiling. As I said, if you multiply a radical by itself, just get rid of the square root and just write an x, much easier. And then root x times 2 root 5, that will just give you plus 2 root 5x, because you multiply the radicals together and you get 5x under the root. And then you finish with that. Now we go here, it's going to be again plus 2 root 5x. And then here, 2 times 2 is 4. And root 5 times root 5 is root 25, which is 5. But I said when you multiply a radical by itself, just get rid of the root and you just get 5 right here. So therefore, this will give me x. 2 plus 2 because they're like terms. So that's going to give me plus 4 root 5x, and that's 4 times 5, which is 20. Again, when you multiply 2 root 5 times 2 root 5, you're supposed to get 4 root 25, but root 25 is 5, so this becomes just 4 times 5. The shortcut I take, I always say if you multiply a radical by itself, you just get rid of the radical sign. Okay, so that's that. Now, this right here, can I multiply these? If they were the same radicand, which is all of them square roots, all of them cube roots, then I could multiply them. But here they don't have the same radicand. This is a 2 here, this is a 3, this is a 4, so I cannot multiply them unless I change them into from this form to that form. So here, the first one is going to be, there's a 1 here that we don't write, and the radicand is 2. Remember I said from last lesson that if you don't write anything, it means a square root, which means there's a 2 here that we don't write. It's invisible too. So that would be x to the power of 1/2 and times x. There's a 1 here, so that's x to the 1/3. Again, I'm using this rule to change from radical form to exponential form, times, and there's a 1 there, invisible 1, so that's x to the 1/4, which gives me x to the power of, the common denominator there is 12, because we're adding radicals. So 12 divided by 2 is 6, 6 times 1 is 6, plus, when you're multiplying variables, you add their exponents. So I'm adding the 1/2, the 1/3, and the 1/4. 12 divided by 3 is 4, 4 times 1 is 4, plus 12 divided by 4 is 3, 3 times 1 is 3. 6 plus 4 is 10, plus 3 is 13. So that will give me x to the 13 over 12. This is how you do common denominator. Go ahead and help yourself any way you like doing common denominator, do it. I highly recommend this method because as you get an advanced math, you'll realize what I'm telling you, that if you do the common denominator here, because it's common, you write it once, and then what I do, I divide this by the bottom, and whatever I get, I multiply it to the top. That's how I do it. Okay, so if they want you to write in radical form instead of exponential form, you could always write it as 12 would be the radicand, and then x to the 13. All right, so here the same thing. You could divide them if they had the same radicand, but this is square root, this is a cube root. So what we need to do here, we need to change the top to x to the 5/2 and the bottom to x to the 2/3, which equals, let me just rewrite that here. That's x to the 2/3 right here. Okay, I just want to see that. I want you to see that's an exponent and it's not written besides it. So, okay. And then when we're dividing, what do we do to the exponents? We minus. So basically we have x to the 5/2 minus 2/3, because that's what the exponents are, which gives me x. The common denominator is 6. 6 divided by 2 is 3. 3 times 5 is 15. Minus 6 divided by 3 is 2. 2 times 2 is 4. And that will give me x to the 11/6, or if you want to write it in radical form, it will be x to the 11. We'll do one more with the multiplication here. So here we foiling, so root x times root x is x. If you want to take a shortcut, you see how these are the same, but they are, one is negative, one is a plus. So you just ignore what's going to happen in the middle, and you could just get away by multiplying this by this, and then multiplying this by this. But we'll just do the whole thing. We'll FOIL the whole thing. So root x times root x is x. Root x times 2 plus 2 root 5 will just give me 2. But write 5x, not x5 there. And then minus the same thing, because you got to FOIL this into here, and you're going to get 2 5x. And minus 2 root 5 times 2 root 5, it's just going to give me 4. And root 5 times root 5 is just 5. And therefore, this is going to give me x. The middle is going to cancel. That's minus 20 right there. And that's your final answer. Okay. Now we're going to go to rationalizing denominators. So here, rationalizing. So here, rationalizing the denominator. What does that mean? It means that we want a rational on the bottom of the fraction. We don't want irrational. This is irrational because it's square root of 5. So to do that, you have to multiply top and bottom by root 5 over root 5. So basically multiplying by this, and whatever you do to the bottom, you do to the top. So if we look at this, 2 times root 5 is just going to be 2 root 5. Of course, you cannot multiply 2 to the 5 because that's radical, that's rational. And here, remember I said when you multiply root by itself, you just lose the square root and you'll end up with 5. It's the square root of 25, which is 5 anyways. So you could take those shortcuts. Now, how about if it's a cube root? When you're doing the cube root, you have to multiply by the bottom, but you have to do that twice. And I tell you why in a second. And whatever you do to the bottom, you do to the top to get rid of the cube root on the bottom. So now maybe this I'll do in details here. So if you look here, it's the cube root, and you could multiply all of these numbers together and you get cube root of 64. And here you're going to get the 3 cube root of 16, which gives me definitely the bottom cube root of 64 is 4. So that's one of the perfect cubes right here. And the 3 cube root of 16, I know I could change that into a mixed radical, but because a perfect cube, which is the 8, goes into 16. So I'm going to change this into 8 times 2, which gives me 3. The cube root of 8 is 2. So that's going to be multiplied by 2. And then I still have the cube root of 2 because I don't know what the cube root of 2 is, over 4. Now you either multiply the top and you get 6 over 4, and then you reduce later. But me, I see the 2 there goes into itself once and goes into 4 twice. And therefore I get 3, the cube root of 2 over 2. And this you cannot reduce because this is rational, this is irrational. All right. Now, how about this one? This one, a lot of students, what they do, they multiply top and bottom by 3 root 6. You don't really need to do that because the 3 is rational, so you don't have to multiply by 3. I advise my students to multiply just by root 6. If you're happier multiplying by 3 root 6, go ahead. You just have to reduce a bit more later. But here, just multiply by root 6. Top, whatever you do to the bottom, you do to the top. So now we have 2 root 6 all over. Root 6 times root 6 is 6, or square root of 36, which is 6. But I just take the shortcut. Root 6 times root 6 is 6. 6 times 3 is 18. And that will reduce into root 6 over 9 because the 2 goes into itself. 1 goes into 18 9 times. Here, to get rid of the square root, now you remember I said just multiply by root 6 here and not the 3. And here, you know, the 3 and the root 6, they are together. It means they are multiplied. So you could just do that, but you could argue here and say, why don't I just multiply by root 3? Unfortunately, you cannot do that with this one because of that minus sign. So that's a binomial. Here, if you look at this here is a monomial, just one term, but here you have 2 terms. And when we have 2 terms, we have to multiply with what we call the conjugate. What's a conjugate? The conjugate, you see how this is a binomial? The conjugate of the binomial on the bottom is the same thing, except you change the sign. That's what we call a conjugate. Okay, and whatever you do to the bottom, you do to the top. Now, you just distribute the 2 here and then FOIL the bottom, which will give you 4 plus 2 root 3 on top. And then on the bottom, you just FOIL this. And 2 times 2 is 4. And then plus 2 root 3 minus 2 root 3 will cancel. And then I'll just write it out for you. So, and then plus 2 root 3 minus 2 root 3, because that's the foiling of that. And then negative root 3 times positive root 3 will just give you minus 3. This will cancel because they're like terms, the opposite signs, and 4 minus 3 is 1. So that would give you 4 plus 2 root 3, and 4 minus 3 is 1. So you don't have to write the 1 on the bottom because everything has a 1 underneath. And here's one more with rationalizing the denominator. This has variables instead of numbers. So remember I said the conjugate is the bottom, the same thing on the bottom, except you change the sign in the middle here. So if it's a negative, you change it to plus. If it's a plus, you change it to negative. So that's a negative, we're gonna change that to plus, and then you know we have to FOIL. And you do the same thing to the, whatever you multiply the bottom by, you multiply the top by. Yeah, and here, if you look at this, root x times root x is just gonna give me x, root x times y, just plus y root x, and then y times root x again, plus y root x, and y times y, just y squared. And here just gonna be root x times root x is x, and then plus y root x, and then minus y root x, and then minus y squared, which gives me, here it'll be x plus 2y root x plus y squared. Here, these are the same, so they're going to cancel with the opposite signs, and I'm just going to have x minus y squared. Just remember that you cannot reduce the x with the x here because this is a trinomial, this is a binomial. That plus sign and the minus sign here doesn't allow you to do that. And also the y squared, you cannot cancel it with the y squared. Okay, so one more we're going to do in solving radical equations, and then this will be it for this chapter. So here we go. This is the first one right here. So here we go, solving radical equations. I think for these, I always like doing finding my domain or finding my restrictions. Okay, so restrictions for radicals, always take what's under the radical, which is x plus 3, and you have to say it has to be greater than or equal to 0. Why does it have to be greater than or equal to 0? Because we cannot square root negative numbers. And therefore, here x would be greater than or equal to negative 3 since you move the 3 to the other side. So here, all our answers have to follow this restriction. Okay, so now to solve this, to solve for the x under the radical, the only way you could do that is by squaring both sides. You square this side and square this side. Because the square always cancels the square root, and you end up with x plus 3 right there equals 81, and therefore x equals 81 minus 3, which is 78. So if you put 78 there, 78 plus 3 is 81. Square root of 81 will give you 9. That's how you check. All right. How about here, number 2? So to get rid of the square root, we always square both sides. But here, if you square both sides here, you'll have to square everything in here. And this will make this a little bit more complicated. But if you do one step before you do that, this will become a lot easier. And the step that you need to do is rewrite this as x plus 1 equals, move that negative 1 to the other side. Okay, so my domain here, x plus 1 has to be greater than or equal to 0. Okay, because that's what's under the square root there, and therefore x has to be greater than or equal to negative 1. Now at this stage, I'm going to square both sides. So we square this side, and if you want to square this side, you just put brackets around there. So squaring of square root of x plus 1 just gives me x plus 1. Here you have to write this twice and FOIL it. So x will give you x squared plus 1x plus 1x will give you plus 2x, and then plus 1. Now move everything to one side, equate it to 0. So 0 equals x squared. When you move this to the other side, it's going to give you minus x. So 2x minus x just gives you plus x. And then when you move this one to the other side, it becomes minus 1. And that would be 0. And therefore 0 equals, I got to factor out an x from here. And again, I get x plus 1. And therefore, x would equal 0 and negative 1. That's when you factor. So this gives you the 0, and this here gives you the minus 1 to make it 0. Now do these two work. this C. Now, if you put in 0 here, so 0, that will give you 0 for the axis. So just checking, okay? Check. So checking the 0 first. So if I put in 0 plus 1 minus 1 equals 0. So now that is 0 plus 1, which is 1. Square root of 1 is 1. So that will give me 1 minus 1, which gives you 0. 0 equals 0. Check. How about if we try the negative 1? The negative 1 will be negative 1 plus 1 minus 1 should give you a negative 1. That is going to give me 0. Square root of 0 is 0. 0 minus 1, just minus 1. Negative 1 equals negative 1. That's check too. Yeah. Now we're going to come to this third one here. It's going to be a bit longer. You have to, I think you have to square it twice, and I'll show you why. So definitely to get rid of the square root, you got to square this side and then square this side right here. And that will give you x minus 5 equals, and this you just write it twice when you square it, so that you could FOIL it that way. So root x times root x is x, and then minus root x, and then minus root x again, and then plus 1. Now I'm going to move everything that doesn't have a radical to this side. So I'm going to move the x to this side, which is going to cancel. And then I'm going to move the 1 to this side, which gives me negative 6. And that would be negative 2 root x. Divide both sides by negative 2. I'll get 3 equals root x by dividing both sides by negative 2. Now I have to square again to get rid of the square root. And that will give me 9 equals x. Okay. So now I just forget to tell you what the domain is here. So the domain x minus 5 has to be greater than or equal to 0. And also this, you have to do it for both. And this says x has to be greater than or equal to 0. This will give you here, x has to be greater than or equal to 5. So this dominates or overrules this. So this will be gone because x has to be greater than or equal to 5. And then the 9 here falls within that domain, so that should work. Now let's check. And I'm just going to put the 9 in for the x here. So I'm going to have 9 minus 5 equals square root of 9 minus 1. So I'm just subbing into the original equation. That gives me square root of 4 right here, which is 2. And that's square root of 9 is 3 minus 1 is 2. So check. And that's it for this chapter. I think that's all you need to do about, or all you need to know about radicals. You just have to go into more detail and do more work on your own and explore to get ready for the test and go get an A+ on your test. And just click on the link that you see, and that's basically the beginning of this chapter, which is converting radicals to mixed radicals and adding and subtracting radicals. Okay, thanks again. Till next time. Bye-bye.